I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In a previous video, we have understand what are the criteria for site selection of wind energy conversion system. In this video, we will mainly focus on what are the different equipments that converts wind energy into electrical energy. So let's get started. Here is the image for components that are used in wind energy conversion system. It consists of many components, but here I have shown some major and main components that every wind energy conversion system must have. The first component is wind. Of course, wind is the main component, which is then followed by aero turbine. Aero turbine is the largest and bulkiest component of entire wind energy conversion system, which is then followed by gear assembly. This gear assembly is used to increase the speed of turbine shaft so that we can get more electrical energy. After that, there is coupling assembly, which basically connects the shaft of gearing assembly with an generator shaft. Combinedly, this both assembly known as mechanical interface, which is then followed by electrical generator, which converts this mechanical energy into electrical energy. And this electrical energy is then utilized to power grid or load. Last but not the least, the main component of entire wind energy conversion system is controller, which ultimately controls all the component in one or another way. So let's see individually them one by one, starting with aero turbine. As I have already said, aero turbine is the largest and bulkiest part of this wind energy conversion system. It consists of an hub on which different blades are mounted. The main function of aero turbine is to convert energy of moving air into mechanical energy. More number of blade on a hub means more power coefficient, but its capital cost also increases. Hence, it is preferable to have 2 or 3 blades. Now, let's move to the next main component of wind energy conversion system, and that is gearing assembly. Gearing assembly is used to increase the speed of turbine shaft. Now, in the previous video, we have understand how the power of wind is directly proportional to velocity raised to 3. Hence, if we increase the speed, we can increase the power by the cube. So, a step-up gear is used to increase the speed of turbine shaft, which is followed by next component, and that is coupling assembly. Coupling assembly basically connects the shaft of gearing assembly with generator assembly, and it transfers the speed and torque of gearing shaft to the generator shaft so that generator shaft can rotate. Now let's move to the next component, and that is generator itself. We know that as generator shaft will rotate, it cuts the magnetic field and produce an electricity or electric current. This electric current then can transfer to power grid or load so that we can utilize this. Now let's move to the next component of wind energy conversion system, and that is yaw controller. When blade faces the wind, area of wind stream swept by wind turbine is maximum, and we can utilize this wind energy to its maximum potential. This can be achieved by controlled arrangement which rotates turbine about its vertical axis or yaw, so that the blade always faces the wind. As wind changes its direction, this yaw controller changes the turbine face. Hence, this turbine always faces the wind. Now, let's move to the next controller, and that is pitch controller. Pitch is the angle made by blade with plane of rotation. By changing pitch, we can increase the speed of turbine blade. Hence, pitch controller is always set in such a way so that we can get maximum speed of wind turbine and we can generate maximum of electrical energy. Now, let's move to the next section, and that is controller. In typical wind energy conversion system, controller perform many tasks. Here are some list that any controller performs. It performs startup and cut of equipment. That means controller decide at what wind speed this entire equipment will start and what speed it will cut off. Next thing that controller perform is the monitoring of generator output and storage of this data. Controller always monitor the electric current produced by generator. Then the controller perform shutdown at very high speed. Whenever wind blows at very high speed, it is very risky for wind energy conversion system and it may get damaged or destructured. So, controller sends the upper limit of wind speed and cut off the plant so that any damage is not taken by wind energy conversion system. Then it has the maintenance mode, and lastly the controller measures the wind speed and wind pressure. Now this concludes all the components of wind energy conversion system. Now let's move to the next section, and that is classification of wind energy conversion system. We can classify wind energy conversion system in many ways. So here is the first criteria, and that is axis of rotation. We can classify any wind energy conversion system by two categories. First is horizontal axis machine and second is vertical axis machine. In horizontal axis machine, the axis of rotation is horizontal and aero turbine plane faces the wind vertically. While in a vertical axis machine, the axis of rotation is vertical and the blade can also be arranged in a vertical position. Here in this image, both type of wind energy conversion system is shown. The first image shows the horizontal axis type machine where the axis of rotation is horizontal, and in the second image we can see that vertical axis machine where rotation axis is vertical. Now let's move to the second classification, and it is based on the size of wind energy conversion system. Basically, we can divide it in a three part. One is the small scale, another one is the medium scale wind energy conversion system, and lastly we have large scale wind energy conversion system. In a small scale, the useful electrical power can be produced up to 2 kilowatts, and it is find its application in remote area or in a farm. While medium scale wind energy conversion system produces electrical energy up to 100 kilowatts. And lastly, the large wind energy conversion system are producing electrical output more than 100 kilowatts. They are used for large application and central power grids. Now let's move to the next classification of wind energy conversion, and that is based on the type of power output. Wind energy conversion system basically has a two type of power output. One is the DC output and another one is the AC output. In a DC output, there are DC generator and alternative refractors. In AC output, we have two subcategories as variable frequency with variable or constant voltage, and second is constant frequency with variable or constant voltage. Now let's move to the next type of classification, and that is based on the rotational speed of wind energy conversion system. We can classify in three categories. First is constant speed with variable pitch blade. The second one is nearly constant speed with fixed pitch blade. This mode is used for induction generator. The third category is variable speed with fixed pitch blade. This mode could imply for constant frequency outputs. And this concludes all the classification of wind energy conversion system. In the next video, we will understand what are the advantages and disadvantages of wind energy conversion system, and we will see different type of wind energy collectors. Till then, keep watching and keep learning. Thank you.